Okay, so in this video, we're looking at the Year 10 non-calculator methods foundation tier for the White Rose Maths case scheme of work or scheme of learning. Okay, so this is aimed at Year 10 students, but it's also appropriate for Year 11 foundation, okay, and Year 9 students, as well as Year 8 and Year 7, as well as even GCSE higher tier as well. Okay, so even GCSE foundation and GCSE higher as well. Okay, question number 1, work out 0.8 times 40. Well, I'm going to do 8 times 40, okay, and then divide my answer by 10. Okay, 8 times 40, well, 8 times 4 is 32, and then add on a 0, I get 320. Okay, my answer will be 10 times smaller than that, so divide that by 10, and I get 32. Okay, because from here to here, I've divided it by 10. So therefore, I'm going to divide the final answer by 10 for that sum to be correct. Okay, by 10, put equals, okay, so it would be 32. Okay, so 32. This next one, 4/9 of 180, so a fraction of an amount. We divide by the bottom and then times by the top. 180 divided by 9 is 20. And 20 times 4, 20 lots of 4 is equal to 80. Okay, so your final answer is 80. So this is what I call a fraction of an amount. We divide by the denominator and then multiply by the numerator. Question number 2, a box of floor tiles costs £18.90. Work out the cost of 12 boxes of the floor tiles. So it's going to be £18.90 times 12. Okay, so times 12. Okay, I can multiply here with or without decimal point. Actually, it doesn't actually matter here. Okay, but at the end here, I've got to be careful. Okay, if we estimate, that's approximately 19 times 10, so the answer should be close here or around 190. Okay, so that will help us place the correct decimal point for our place value. So the answer's around £190. Okay, or just a bit over. 0 times 2 is going to be 0. Okay, 2 times 9 is going to be 18, so 8, carry the 1. 2 times 2 is going to be 16, plus the 1 is going to be 17, so 7, carry the 1. 2 times 1 is 2, plus the 1 is going to be 3. I'm going to put the placeholder there. 1 times 0 is going to be 0. Okay, 1 times 9 is 9. 1 times 8 is 8, and 1 times 1 is 1. Okay, adding our answers together. Okay, 0 plus 0 is going to be 0. 8 plus 0 is going to be 8. 7 plus 9 is going to be 16. Okay, so 6. Carry the 1. 1 plus 3 is 4. Plus the 8 is going to be 12. Okay, so it's going to be 12. So 2, carry the 1. 1 plus 1 is 2. Okay. So hopping the decimal point back here, so 2 places, the answer is £226.80, okay, for that one, okay. So we've put our place value in the exact correct place, okay, because initially from our rounding, the answer I said is obviously close to 90. Obviously, it's above 190, sorry, not 90, 190, okay, because I'm times it by 12 and not by 10. Okay, but that's your correct answer. Okay, question number 3. Work out an estimate for this sum. Whenever you see the word estimate, think of rounding to one significant figure. So that'll be 60 times 10. Okay, divided by 0.5. Okay, so essentially I'm rounding the top numbers, so the numbers on my numerator, I'm rounding them to the nearest 10, and then I'm rounding the decimal to one decimal place. Okay, so you are always rounding. Oh, sorry, it should be 10 not 13. Sorry. So you are always rounding it, so it's the first non-zero number, and then the rest are going to be zeros. Okay. for a significant figure. Okay, so I rounded 57 here to the nearest 10, I rounded 13 to the nearest 10, okay, so I get 1 sig figure as my answer, and then I rounded 0.49 to 1 decimal place, because 0.49 here to 1 significant figure is 0.5, okay, which is, yeah, rounding it to like the nearest 10th, okay. So 60 times 10 is going to be 600. Okay, 600 divided by 0.5. So divided by 0.5 actually doubles your answer actually, yeah. Because if you think of it, halves going to 1 twice. So if I double it actually, so it's going to be 600 times 2. Okay. Which is equal to 1,200. So dividing by 0.5 actually, you're actually multiplying your answer by 2. Okay, so yeah, it's a little fact there. So dividing by 0.5 here actually is the same as multiplying the answer by 2. Okay. Question number 4, subtracting fractions. Okay, so I'm going to write it under a common denominator. So I'm going to do 8 times 2, which is going to be 16. Then I'm going to do 3 times 5, which is going to be 15. So put the minus sign. Okay. All divided by the product of the denominators, so 3 times 8, which is going to be 24. Okay, so I've done what I call cross multiplication here to work out my answer. So I've multiplied the leading diagonals together, and then I've multiplied the two denominator numbers together. Okay, so 2 times 8 is 16, 3 times 5 is going to be 15. Okay, so you have 16 24ths minus 15 24ths, which gives you the answer of 1 24ths, okay, or 1 over 24. Okay. For this next question, I've got 1/12 divided by 3/4, so it's what I call the KFC method. You keep the first fraction, so K stands for keep, so you keep the first fraction or number, you flip the second, so you find the reciprocal, okay, or the inverse, okay, of the second fraction. So K is for keep, F is for flip, okay, so you flip the second fraction, and then C is for change. You change the division to a multiplication, okay. Now when I multiply fractions, I just multiply the numerators and the denominators together, okay. So I multiply the numerators together and the denominators together. 1 times 4 is 4, okay, and 12 times 3 is 36. So I get 4 36ths. Okay, dividing top and bottom by 4, I get the answer of 1/9. Okay, so the answer is 1/9 or 1/9 in its simplest form. Okay, so dividing fractions, yeah, remember that rule, guys. Okay, keep, flip, change, the KFC method. Okay, and when you're adding or subtracting fractions, you must have a common denominator. Okay, I've done it here using the cross multiplication here, or the butterfly method, where you multiply the two leading diagonal numbers together, and then it's yeah, and then you would obviously add or subtract here, depending on what you're adding or subtracting, and then you are dividing it by the product of the denominators, okay, and then you simplify your answer, yeah, where possible, okay. Question number 5, a small town has a population of 3,500 people to the nearest 1,000. What is the least and the greatest possible values for the size of the population? Okay, so the least amount will be 3,000, okay, 450. Okay, because if I round that here to the nearest 1,000, that's my thousands column, so I look at the next digit across. If it's 5 or more, then I round up. If it's less than 5, then I round down. Now for greatest here, I've got to be a bit more careful and cautious here. So the greatest number, sorry, nearest 100 actually, not nearest 1,000, sorry. Nearest 100, yeah, it's going to be that, okay, for your least number, okay, because it can't be below that, because if it's 49, then 49, yeah, doesn't obviously round up here to 100 here, to the nearest 100, sorry, not 1,000, okay. So the greatest will be 3,549. And the reason for that is it can't be 3,550 because that rounds up to 4,000. Sorry, to 3,600, sorry, to nearest 100. So it has to be that one, okay? So you've got to be very careful here, okay? So this is looking at what we call upper and lower bounds, okay? This next one. Sorry, guys. A book is 19 centimeters long, truncated to the nearest centimeter. So yeah, truncated just means like cut off, rounded off to nearest centimeter. Complete the error interval for the length L of the book. So the smallest possible value it can be will be 18.5 centimeters. And the largest one, okay, yeah, it is less than here, will have to be 19.5, okay. And the reason why this time I've put 0.5, guys, yeah, and I didn't put like the 50 here, is because this is an inequality. So the length can take the value of 18.5 or more centimeters, but it has to be explicitly less than 19.5 or smaller than 19.5. Okay, so reading the inequality from left to right, okay, being very careful. Okay, it's not less than or equal to 19.5 actually, because it can't include 19.5. It has to be explicitly less than or smaller than 19.5. Okay. Question number 6, work out the area of the circle. Give your answer in terms of pi. Well, the formula for the area of the circle is pi r squared. So pi multiplied by the radius squared. The radius here is 7. So I'm going to have 7 squared times pi. Well, 7 squared is 49. Okay, 7 squared means 7 times 7. Okay, 7 sevens are 49. Times that by pi, and I get the answer of 49 pi. Okay, I'm going to be careful actually and clear. So it's 49 pi centimeters squared. Okay, for your units. Okay, remember that pi is just a number. Pi is just a constant. Okay, I'm leaving my answer here in terms of pi because this is what I call my exact answer. Okay, so this is the exact answer. Okay. If it appears on the calculator paper, yeah, it would say like round your answer, yeah, to like the nearest, yeah, like whole number, or 1 decimal place, or 2 decimal places, or 3 decimal places, or 1 significant figure, or 2 significant figures, or 3 significant figures. Okay, yeah, but this is what I call my exact answer. Okay, because it's not actually been rounded yet at all. Okay, it's what I call my exact solution. Okay, or exact answer. Okay, because pi is what I call, yeah, a irrational number. Exact answer, which means that that when you enter it in your calculator, obviously your calculator will obviously truncate, based on the number of digits that it can display on a calculator. Okay, so there is what we call some rounding errors even within a calculator. Okay, this is what I call my exact answer. So this sort of question can and possibly will appear on a typical GCSE paper 1, okay, higher or foundation tier, okay, this sort of question, okay. So make sure that you are happy in writing your answers in exact form, i.e. in terms of pi or in terms of surds, okay, for your paper 1 exam. Okay, question number 7. Annie needs to make 75 pancakes. In each pancake, she uses 25 milliliters of milk. Each bottle of milk is 500 milliliters. How many bottles of milk will she need to buy? Yeah, does she need to buy altogether? Okay, so in each pancake, so if I do 25 multiplied by 75, that will tell me the total amount of milk, that is going to be needed for the 75 pancakes, okay? So working this out, so we work out to the side here, okay? So doing some practice here with our long multiplication, okay? So 5 5s are 25, so 5 carry the 2. 5 2s are 10, plus the 2 is going to be 12. Okay, put a 0 there, because it's a placeholder. Okay, because it's 70 times 25 now. 7 times 5 is going to be 35. 5 carry the 3. 7 times 2 is 14, plus the 3 is going to be 15. Okay, adding my answers together, I get 5, 7, 8, and 1. So yeah, so in total, she is going to need 1,875 milliliters of milk, okay, for the 75 pancakes. I'm now going to divide this number by 500, okay. It is going to give me a decimal answer, okay, but I'm gonna have to round my answer here to the to like the nearest whole number, because in this context, I can't have half a bottle of milk, okay. Although technically, yes, half a bottle would obviously be 250, but I'm classing each bottle to be 500. Okay, I'm working with 500. So 500, 1,000, 1,500, or 2,000. 2,000 is too big. So it's going to be 3 remainder something. Okay, amount. Okay, so that means I'm going to need 4 bottles of milk. Okay. So 4 in total, because I can't have that remainder. Okay, so that remainder will have to come out of the 4th bottle. Okay, so she will need 4. Okay, but obviously not all 4 will obviously be used as so a portion of the 4th bottle will have a bit left over. Okay, but because I can't have like a remainder in this context, the remainder has to be in the 4th bottle. Okay, if that makes sense. Okay. So 4 bottles are needed altogether. Okay, you just need to buy altogether. Question number 8. A family buys 2 adult tickets and 3 children tickets to enter a water park. They have a 25% discount voucher. After using the voucher, they pay £72. The original price of a child's ticket is £16. What was the original price of an adult ticket? Okay, so taking our time here. So first of all, so it's giving you the final answer here, and it wants you to obviously work out the original amount. Okay, so first of all, if I subtract, 48, because so the original price, obviously, it's gonna be 16 this year. So ignore me for a second, sorry. So that'll be 16, 32, 48. So that'll be £48 there. Okay. Now for adults here, we'll call that X. Okay. So we've got an equation. So we've got X here, which is the price of an adult ticket, okay, plus the price of a child ticket here, plus 16, okay. So this is what we call my original, okay. Now they have a 25% discount voucher, so they are paying 75% of the amount, okay. So I'm gonna multiply this, okay, by 0.75, okay. Because I've taken off 25%, and 25% as a decimal is 0.25. So they're actually paying for 75% of the total amount. Okay, hopefully it makes sense there. Okay, so after this reduction, okay, they get an answer of £72. Okay, so I've formed my equation here and I have to rearrange it. Okay, so first of all, okay, I'm going to divide everything by 0.75. First of all, and then I'm going to subtract 16, okay, and that will tell me the price of one adult ticket, okay. Because I know that the price of a child ticket is £16. Okay, which is why I've put it in a bracket here, because I'm doing the adult price plus a child's price, and I'm multiplying that by the discount voucher, by the discount amount, sometimes by 0.75, and I get the answer, okay, and that's how much they pay. Okay. No, I think I might have made a little mistake actually here, because I think it should be I think it actually should be X. Sorry, it should be 2x here for 2 adults here. So 2x plus 48 actually, so 48 actually, but the rest of it it's still going to be correct. Okay. So working this out, so I'm going to get 2x plus 48. Okay. So doing this on my calculator for this part here. So 72 divided by 0.75. So doing this or working this out, yeah, in my head actually, yeah. So that's dividing by 3/4, so I'm times it by 4/3. Okay, so yeah, so you are multiplying this by 4/3. Okay, so I can divide top and bottom by 3, and I get 1, and I get 24. 24 times 4 is going to be 96, okay, because 24, yeah, times 4, if I double it and then double it again, okay, if you're ever multiplying by 4 in maths, okay, you double it and then you double it again, okay, a little trick there. So that has to equal to 96. Okay, rearrange this equation by subtracting 48 on both sides and then dividing through by the 2. So we get 2x is equal to 48. Okay. And then dividing through by 2. Okay, dividing both sides by 2. Okay, a half of 48 is going to be 24. Okay, so each adult ticket, okay, or the original actually, yeah, cost £24. And we can check our answer because, okay, if I do 24 add 24, add 16, add 16, add 16, okay, I'll get an answer here. So I'll get 96, okay. If you do 96 times 0.75, okay, that does give you the answer, okay, of 72. Okay, so yeah, obviously double checking it, yeah, on my calculator to obviously make sure. So you got 96, okay, times 0.75, and that gives you an answer of 72. Okay, so that does confirm my answer to be correct. Okay, and just to be clear, guys, so the 0.75 shares come from 25% reduction. If something is reduced by 25%, then I'm paying 75% of the total amount. Okay, so yeah, just to be very, very clear, guys. Okay, if there's a 25% reduction, then yeah, like the leftover part, okay, that's how much I'm paying actually. So I'm paying 3/4 of the amount and I'm saving 1/4. Okay. Okay, so yeah, the save there is 25%, but I'm paying 75%, okay, yeah, of the total amount, okay, and that's how, yeah, discounts work, okay. So that's why, yeah, in shops, like, yeah, if you see something, yeah, that's like 40% off, it means that you're paying 60% of the price, okay. Or if something's 20% off, yeah, like in a shop or like a clothes or food store, then you're paying 80% of the amount, okay. So hopefully that makes sense there, okay. But this one, yeah, this one, it is more a reverse percentage question. Okay, this one, yeah, is giving you the answer, and you have to actually work backwards here. So this is what I call a reverse depreciation question. Okay, a reverse percentage decrease question. Okay, yeah, so it is a reverse percentage decrease question. Okay, but hopefully it makes sense there, guys. Okay. So yeah, if I messed up at all, yeah, on any part, but hopefully it makes sense. Okay, right, guys, that's the end of today's video. Okay, looking at your foundation tier non-calculator methods. Okay, for year 10 maths. Okay, this is also appropriate, yeah, for GCSE foundation, GCSE higher, especially these later questions. Okay, and also, yeah, key stage 3 level students as well. If you found it useful, okay, don't forget to like, don't forget to comment, don't forget to subscribe, and I'll see you all inside the next video. Okay, and make sure, yeah, that you click that bell icon so you are notified of my next upload, okay, on this channel, okay, for key stage 3 maths, key stage 2 maths, GCSE maths, and even the AS and A2 pure maths content. Okay, thanks for watching, and I'll see you in the next one. Okay, take care, all the best, and I'll see you soon. Okay, bye for now.